Okay, now can you see my screen? Okay, thank you. So we will continue, okay. So wait a minute. Okay, so now I think we are on sampling. No? We are doing sampling actually. Okay, so we are in this stage still. Okay, so we know that we learned that, okay, the real world is continuous time and also analog. Okay, so continuous time means you know that the the time is continuously varying in real world. No, in real life the time is continuously varying, and also all the parameters are analog. The magnitude of the parameters are analog. For example, if you consider a change temperature change in daytime, let's say that from 6 a.m. to 12 p.m. likewise. Okay, so from 6 to 12 the time is continuously varying. Okay, continuously varying from 6 to 12, and also the temperature also continuously vary. uh, maybe uh, maybe from morning to up to 12 p.m. temperature will be high. Okay, so if we consider again up to 7 p.m. or something, again temperature may be getting low. Okay, so time is changing continuously, and the temperature value also changing continuously. Amplitude also changing continuously. So it will be analog signal. Okay. So now up to now you should know what are the continuous time signal and what are the discrete time signal and what is analog signal and what is digital signal. Okay. So in our interaction session also we have discussed these things. Okay. So now you should have idea. Okay. So if you have any concern or doubts, okay, please ask me, then I can explain these things. Okay. So if you couldn't answer here, okay, in this session, you can come and meet me at the lab, okay, in optical lab, okay. Then you can ask any question. Okay. So it is my responsibility to explain these things to you. Okay. So if you couldn't understand anything, sometime it may be my problem also. Okay. Maybe my method is not appropriate for you. Okay. So if you couldn't understand the things what I'm saying, maybe it is also my fault. Okay. Not only your fault. හරි. ඔකට්ටේට මං කියන දෙයක් තේරුන්නේ නැත්නම් ඒ මං කියන එකේ වැරද්දක් වෙන්න පුළුවන්. හරි. ඒක සමහරට ඔකට්ටේගේ වැරද්දක් වෙන්න නැති වෙන්න පුළුවන්. හරි. එතකොට මොකක් හරි දෙයක් තේරුන්නේ නැත්නම් ඔය කට්ටිය ඇවිල්ලා අහන්න. හරි. එතකොට මට ඒක අපව කියලා දෙන්න පුළුවන්. ඒත් තේරෙන්නේ නැත්නම් ඔය කට්ටියට මේ YouTube එකෙන් හරි බලලා එහෙම නැත්නම් මේ ඉන්ටර්නෙට් එකෙන් හරි සර්ච් කරලා ඉගෙන ගන්න පුළුවන්. හරි. Okay. So these things we have discussed, so I'm not going to tell again these things. Okay, I'm not going to repeat them again. Okay. So real world is continuous time analog. Okay. But we also but we like for digital processing. Okay, we like digital processing. Okay, so we also discuss what are the advantage of this digital processing. Okay, what are the advantage of digital processing? We have already discussed. Okay, design is easy design. Okay, low power. Okay, easy analysis. Okay, so these are the three main advantage of digital processing. Okay. Uh, okay, so this continuous time analog signal should be converted to a digital signal first using analog to digital converter. Then when you give it to again to the real world, okay, you have to again convert this digital signal into analog, okay, analog form using digital to analog converter. Okay, so this is analog to digital converter. It convert analog signal into digital. Then you can process it. Then after processing, you can convert this digital signal into analog signal using DAC, digital to analog converter. We normally refer it as DAC. Okay, then you can give it to the real world. Okay, so here we have analog signal, here we have digital signal, again here we have analog signal. Okay, so this conversion should be done. Okay, and I told you that the analog to digital conversion, okay, analog to digital conversion, ADC conversion, okay, has three main steps. Okay, okay, if you have analog signal, okay, if you have analog signal, and if you want to convert it to digital signal, okay, there are three steps, main steps. Okay, first one is sampling, second one is quantizing, okay, third one is encoding. Okay, encoding. Okay, this is sampling, this is quantizing, and this is encoding. Okay, then we will have a digital signal here. Okay. So this is the analog to digital conversion process. Okay, so there are three main processes: sampling, quantizing, and encoding. And now we are focusing on sound. Okay, we are focusing on this signal. Okay, in this step. Okay, we are focusing on this step, sampling step. Okay, okay. Now I have explained what is sampling. Okay, I have explained what is sampling. Okay, so again I will explain the same thing here. Okay, so I am repeating again what we have done in the interaction session. Okay, I am repeating it again here. Okay, so try to understand this. Okay, try to understand this. Okay, now you have a signal. Okay, let's say that you have a signal. Let's say that it is xt. Okay, it is like this. So your signal is like this. Okay, so this is time. Okay, so this is xt and this is time. Okay, and you have a value here. I will try to draw it clearly again. Okay, so I need your focus here. Okay, please focus this concept. Okay, it is very important to understand this concept. Okay, so let's say that we have a signal like this. Let's say that this is a voltage signal or something. Okay, so you have a value here and this is a time value. Okay, let's say that this is 0 to t or something. Okay, so you have a value here a. Okay, so this is your signal. Okay, okay, tell me, this is a continuous time or discrete time signal? Tell me, is this continuous time or discrete time? And you should be able to identify this signal, whether it is continuous time or discrete time. Please tell me, is this continuous time or discrete time? Make a discrete time signal lega the continuous time signal lega. Please answer. Is this continuous time or discrete time? I need your answer. You can give me the answer, whether it is correct or wrong, okay? That is fine.
Continuous
I just
signal.
need the answer, okay?
Continuous signal, sir.
Please answer. Is this continuous time or discrete time?
Continuous time.
This signal is continuous time or discrete time?
Continuous.
Please answer. Is this continuous time or discrete time? Yes, that is, yeah. Thank you. Okay, what about others? I got only one answer, actually. Yeah. Yes, thank you. Okay. So this is a continuous time signal, okay? How you identify whether this is continuous time or discrete time? So you can see that the time is continuously changing, okay? So this is a from here to here, from 0 to t, time is continuously changing, okay? So this is definitely a continuous time signal. And also this is an analog signal, okay? Because this amplitude also changing continuously, okay? So there are infinite number of times value between this 0 and t, and there are infinite number of amplitudes level between this 0 and a, okay? So this is continuous time, this is the analog signal, okay? Okay, now I am doing this kind of things, okay? So let's say that this is a voltage signal, okay? This is a voltage signal. Can anyone tell any example that we can get this type of signal? Any example? So practically this shape we can obtain, okay? This shape, the voltage change in this shape, this type of signal we can obtain practically. Can anyone tell one example? One example for this signal?
Continually reduce the voltage.
I will show you, okay? Okay, so what is this? What is this signal? So this is the same. I also draw this kind of shape signal, no? So what is this signal actually? This is the capacitance discharging curve, okay? This is the capacitance discharging curve, okay? So if you have a charge capacitor, like this, okay? Like this, okay? And if you connect the oscilloscope here, you have to connect digital signal oscilloscope here, okay? And if you have a switch like this, okay, if you have a switch like this, okay, this kind of switch, okay, so this capacitor is already charged, okay, and you have to put the resistor also here, okay. And if you close this switch in oscilloscope, you can see this kind of signal, okay. So this is the voltage of the capacitor is getting low. It is discharging, okay, like this, okay. So the same curve we see, okay, the same shape. Okay. So practically you can get this kind of signal. So this is the capacitor discharging curve, okay. Okay. So practically you can generate this kind of signal, okay. Okay. Anyway, now I am doing this kind of things, okay. So let's say that this is a voltage signal, okay. Now, let's say that I use a capacitor here like this, okay. Now I have a capacitor, okay, charge capacitor, okay, like this, okay. Now I have a switch like this, okay, switch, and here I connect a voltmeter, okay. I connect a voltmeter. Voltmeter means I can get a multimeter and I can measure the voltage, no, okay. So is my connection okay? I have parallelly connect the voltmeter and I have serially connect a switch, no? So my connection is okay. Okay. Now, what happen if I suddenly close this switch? Okay. Suddenly close this switch, what happened? What happened? Okay. So I can see a reading on this voltmeter, no? I can see a reading on this voltmeter. Okay. So if I mark that voltage, if I mark that voltage, so let's say that I off on this switch at t equals 0. T සමානයි බිඳුවේදී මම මේ switch එක off කරා. On කරා. හරි? So I can see a voltage value. Now I mark the voltage value here. Okay. So that let's say that that voltage value is any value. We don't know the value. Okay. Now suddenly the voltage value is I can see a voltage value because of what? Because when you turn on the switch, okay, the current, very small current is flowing through this discharge in the capacitor, then I can see a value here. Okay. Again, so again after some time, okay, so I suddenly switch off this, okay, switch off the switch suddenly. ඒත් එක්කම මම මේක on කරා, ඒත් එක්කම off කරනවා. හරි? So I can see a voltage value. Okay. Again, I close this after some time. Okay. Again, I close this. Okay. So you can see that when I first close this, some charges are flowing in this direction. Okay. So the charge reduce. Okay. Charge of this capacitor is reduced. That means voltage across this capacitor also reduce. No. Okay. So when I press this switch again I can see a voltage, but that voltage is somewhat less than the previous one. Like this I can get. Okay. Let's say that I on this switch after ts second. Okay. After ts time I on this switch. Okay. Then suddenly off it. Okay. Again after ts time. Again after ts time, I on this switch. Again, I can get the value here, voltage value. Okay. Again after ts time. Okay. Again, I turn on the switch. Then I mark the voltage value. Okay. Then I mark the voltage value and off the switch. Okay. Likewise, I measure the voltage after every ts second. Okay. ts second until this capacitor is fully discharged. Okay. So I will get this kind of signal, no? Okay. I will get this kind of signal readings. Okay. So let tell me this signal is continuous time or discrete time. This signal is discrete time or continuous time. Please tell me. Please tell me this signal is continuous time or discrete time. I need your answer. This signal is continuous time or discrete time. Discrete time or continuous time. This is the measured
Discrete.
signal, okay?
Discrete time signal, sir.
Tell me this is discrete time or continuous time. Yes. What about others? Please give me, please answer the guy also. What is this? Discrete time or continuous time? I got only one answer. It is a simple question, okay? Is this discrete time or continuous time? Okay, so you can see that if you consider any time points, let's say that from here to here, so you have only 1, 2, 3 times value. Okay, so that time values you can calculate. Okay, you can count these time values. Okay, it is 1, 2, 3 between these time limits 0 to 2 TS. There are only 3 times values. Okay, so between this one and this time, there are discrete time values. Okay, not continuous time value. Okay, so definitely this is a discrete time signal. Okay, so this is a discrete time signal. Correct. Okay, now, okay, so what you have done here? What you have done here? You have just sent this signal through a switch. Okay, like this. You send this signal through a switch. Okay, then you turn on this switch at after every TS second, okay, and you collect a voltage value, okay, you collect a voltage value. In other words, you collect a voltage sample, okay. So this is a voltage sample actually, okay. So this is the zeroth voltage sample you collect, you measure. This is the first voltage sample. This is the second voltage sample. And this is the third voltage sample. And this is the fourth voltage sample. Okay. So you on this switch at T is equal to 0. Then you collect one voltage sample. Okay. You get that value. Okay. Again, after T second, TS second, you on this switch and suddenly off, okay? Then again, you can get a voltage sample, okay? So that value can be any value, okay? Again, after another TS second, you get another sample. So on, after TS second, you are collecting the sample, you are getting the sample, okay? So what you have done here, okay? So this is a continuous time signal, okay? Using a switch, you get some sample, voltage sample of this signal, okay? So using this switch, actually what you have done here, you have sampled the signal, no? You have sampled the signal, this continuous time signal, you have sampled, okay? That means you are getting some sample with the specific certain duration. Within certain duration, for certain time, after certain time, you get voltage sample, okay? In other words, you sample this signal, okay? You sample this signal and you get this signal, okay? So you can see that after sample the signal, so this is the continuous time signal, no? After sample the signal, you can see only samples are there, okay? So this will be a discrete time signal, okay? So what happened? You convert this continuous time signal into discrete time signal by sampling it, okay? Okay. So actually that is the theory, okay? That is the sampling process. In sampling, what we are doing? Sampling, what we are doing? We collect voltage sample, okay? Amplitude sample, okay? Because this is a voltage signal, we can say voltage sample, okay? If this is a temperature signal, we get temperature, okay? So anyway, we get the amplitudes, okay? So this value is the amplitude, okay? That is the common name for this value, okay? So this value can be anything, okay? It can be voltage, it can be power, current, temperature, humidity, anything, okay? So what we have done is we sample this signal, okay? We sample this signal and we convert this continuous time signal into a discrete time signal, okay? So that is the sampling process, okay? So sampling process means converting continuous time signal into discrete time signal. That is the sampling process, okay? So that is very important, okay? So if I ask the question, what is sampling? What is sampling? What should be your answer? Okay. So you can explain it, okay? If you have a continuous time signal, you are getting sample, okay, with certain time duration, okay, okay. Then it will be a sampled signal or discrete time signal, okay? So this sampling is the process of converting continuous time signal, okay? Process of converting continuous time signal into discrete time signal. So that is the sampling, okay? That is the sampling, okay? Now, um, okay, now, so you can see that after every TS second, we are collecting sample, no? After every TS second, we are collecting sample, okay? So you get the one sample within this TS time, correct? Okay, okay. Within TS time, with this TS time, okay, with this TS time, okay. What you are doing? Okay, you get one sample. So this TS means what? time to get one sample, no? Time to get one sample, okay? So this TS is time to get one sample, okay? So you can see that, okay? Okay, if you consider this signal, okay? If you consider this signal, okay? So you get one sample here. Let's say that that is a 0th sample, okay? And after TS second, again you get another sample, another one sample, another one, okay? So this is the first sample. Again after TS second, you get another sample, that is the second sample. Again after TS second, you get another sample, that is the third sample. Again after TS second, you get another sample, that is the fourth sample, okay? So this is the 0th sample, this is the first sample, this is the second sample, this is the third sample, and this is the fourth sample, okay? Okay, so you get this sample, okay? You get this sample, okay? So what is this TS? That is the time to get one sample, okay? You spend TS time to get one sample, ne? Sample එකක් ගන්න ගත වන කාලය තමයි TS. හරි? We call this sampling time. Okay, we call this sampling time. Sampling time. Okay, this is sampling time. Okay, now I ask you a question. Okay, how many sample? How many sample you get for 1 second? How many sample you get for 1 second? Please try to give answer for this question. Use your brain and tell me. How many sample you get from 1 second? Okay, how many sample you can get for 1 second duration? For 1 second duration, how many sample you can get? Please calculate and tell me. You have enough data to calculate this. Yeah. Okay. Okay, take 10 minutes. No need take 10 minutes, 5 minutes, take 5 minutes and tell me the answer. Give me answer. All of you give me answer. If it is wrong, that is enough. No problem. Don't worry. Okay. So just try to give me answer. කොච්චර sample ප්‍රමාණයක් තප්පරයකදී ගන්නවද? හරි? තප්පරයකදී ගන්න sample ප්‍රමාණය කොච්චරද? ඒක මට හොයලා කියන්න. දැන් ඔය තියෙන දත් වලින් එක කියන්න පුළුවන්. හරි? ඔය ඔක්කොමලා උත්තර දෙන්න. වැරදුනාට කමන්නේ. That is okay. I am just expecting the answer from you. Okay? Please. Okay, can anyone answer? Actually, that is a simple question. Okay, I just ask in a simple question. Okay. So you can see that. Okay, if you consider this signal, okay, please consider this discrete time signal. Okay, this one. Okay. So what you can see? You get here you get one sample. After TS second, again you get another sample. After another TS time, you get another sample. Again you get another sample. You get another sample. So what is TS? TS means okay. TS means what? That is time to get one sample. That is time to get one sample. Okay. So this is a sample number, one sample. Okay. So if you need to find, so this is for TS time, you get one sample. Okay. So if you want to find number of sample per 1 second, what you have to do? You have to divide this side TS and also this side TS. Okay. So that is the number of sample you get for 1 second. Okay, 1 over TS. Okay. So this is the number of sample. This is the number of sample. you get for 1 second. This is the number of samples. If the sampling time, if the sampling time is Ts, okay? So 1 over Ts means number of sample per second, okay? So what is Ts is sampling time. Ts is sampling time, okay? 1 over Ts is number of sample per second, okay? Number of sample per second, okay? And we call this sampling rate also. This is sometimes called sampling rate, or what is the other name? Sampling frequency. Sampling frequency. Okay. So this is very important parameter. Okay. So that is called sampling rate or sampling frequency. Okay. Okay. So sampling frequency, Fs, normally it is referred in Fs. This is sampling frequency. Sampling frequency is equal to 1 over Ts. This is sampling time. This is sampling time. Okay. So you should keep remember this this relationship. Okay, this is very important. Okay. So sampling time means number of sample per second. Sampling frequency means number of sample per second. Sampling time means time taken to get one sample. Okay, so you should understand these two parameters very well. Okay, so this is very important. If I ask you what is Fs, you have to answer. That is the sampling frequency or sampling rate, number of sample per second. Okay. And if I ask what is Ts, that is sampling time or time which is taken to get one sample. Time to get one sample. Okay. So that is the sampling time. Okay. So you should know these two parameters and you should know this relationship. Okay. So this is a very simple relationship. Okay. So I think everyone can understand this. Okay. Okay. Now I will give you a little exercise. Okay. Please try to do this one by yourself. Okay. Let's say that. Okay. Let's say that. Okay. Let's say that. Give me a moment. Okay. Okay. I just take arbitrary signal. Okay. I'll take a signal like this. Okay. So my signal is like this. Okay. It is reducing like this. Okay. And it is again increasing like this. Okay. Up to this. Okay. So this is my signal. Okay. This is my signal. This is my signal. Okay. This is my signal. Okay. Let's say that this value is 5. This value is 5. Okay. This value is 5. Let's say that this is let's say that this is 2 seconds, 1 second. This is 1 second. Okay. And this is 2 seconds. Okay. And let's say that this is 0.5 seconds. Okay. and this value is 2.5, okay, and this value is 1.5, okay, 1.5, okay. Now you are going to sample this signal. Now you are going to sample this signal, okay. So what you have to do is you have to switch on and off, okay. So let's say that your sampling frequency is 2 hertz. Your sampling frequency is 2 hertz, okay. Your sampling frequency is 2 hertz, okay. Now tell me, okay, what is the zeroth sample value, first sample value, second sample value, third sample value, and fourth sample value. Tell me, what is the zeroth sample value? Let's say that you off this switch at t is equal to 0. Okay. So this is the first time you switch off this signal. Switch off this switch. Okay. So that means you are starting the sampling at t equal 0. You start in the sampling. Okay. Start in the sampling at t equals 0. Okay. So what is the zeroth sample? What is the first sample? What is the second sample? What is the third sample? And what is the fourth sample? Okay, please tell me. So this kind of question, the some not this is very simple question. Okay, but this kind of question will come to exam also. Okay, so I will give you a sampling frequency or sampling time. Then I ask you to draw the signal, sample signal. Okay, so you should be able to do this kind of work. Okay, so this is somewhat simple one. Okay, so I hope everyone can do it. Okay, everyone can do it. So try this by yourself. Find these, try to find these values. Try to find these values. Okay, and I will do this one. Okay, so after I did this. Okay, you should be able to do this. Okay, okay, so try to do this. Try to do this by yourself. Take 10 minutes. Take 10 minutes and try to do this. Okay. Have anyone tried to do this one? Did you get any answer for zeroth, first and second sample? Okay, so I will do it for you. Okay, and I will upload this lecture again and also do these things by yourself also. Okay, you have to do this by yourself. Okay, and you have to practice this. Okay. So what I am asking? Okay, so here you are given a signal. So this is an electrical signal, voltage signal. Okay, so voltage is somehow changing like this. Okay, it is starting from 5. At 1 second, it is let's say that this point is 1 or something. Okay, I forgot to mention this one. Let's say that it is 1.25 or something. Okay. 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 And this one and this one. Okay. So the voltage is changing like this. Okay. And now I am going to sample this signal. What I'm going to do is I'm going to sample this signal. Okay. So this signal, this is time. Okay. This is time measured in second, and this is the amplitude. Okay. So amplitude is a voltage. It's measured in voltage. Okay. So now I am going to sample. What is my sampling frequency? That is 2 hertz. Okay. My sampling frequency is 2 hertz. Okay. So what is that mean? I am getting two sample per 1 second. Okay. Sampling frequency 2 hertz means sampling rate or sampling frequency 2 hertz means I am getting 2 sample per 1 second. Okay. That is the number of sample per second. That is the sampling frequency. Number of sample per second. So now my sample frequency is what? 2 hertz. Okay. 2 hertz. Hertz mean 1 over S. You get hertz. Okay. So now what is your sampling frequency? Sorry. Okay. So your sampling frequency is 2 hertz. That means 1 over 2 hertz. That will be. Okay. So, sorry. Okay. So hertz means 1 over second. Okay. That is hertz. Number of samples per second. Okay. So this is 2 sample per second. I am getting 2 sample per second. Correct? Okay. So what is the sampling time? I am going to get 2 sample per second. Okay. So what is the sampling time? Sampling time means what? Sampling time එක කියන්නේ මොකක්ද? Time for one sample. Time taken for one sample. That is the sampling time. Okay, TS. Okay. Now my sampling frequency is 2 hertz. Okay. Then if I want to find sampling time, that is the time taken for one sample. Okay. So within 1 second, I am getting 2 samples. So to get 1 sample, I have to take 1 over 2 seconds. Okay. That means 0.5 seconds. This is my sampling time. Correct? Okay. So you can use this relationship also. Okay. Using this relationship also, you can find the same thing. Okay. So using the cross product, you can say that TS is equal to 1 over Fs. I am getting this one here and this one here. Cross product. Okay. Okay. So this is the equation. Okay. So sampling time Ts equal to 1 over Fs. Okay. So Fs is 2 seconds, 2 hertz. So Ts is 1 over 2 hertz. So it will be 0.5 seconds. Okay. So this is my sampling time, 0.5 seconds. That means what? I am getting sample for every 0.5 seconds. Okay. So I am getting sample at every 0.5 seconds. Okay. So at t is equal to 0, I am starting sampling. Okay. That means t is equal to 0, I am getting 1 sample. Okay. හරිද තේරුණාද? දැන් මේ සිග්නල් එකක් මට දීලා තියෙනවා. ඒක අපිට sample කරන්න. Sample frequency එක 2 hertz. හරි. Sampling frequency එක 2 hertz කියන්නේ that is the sample per second. Number of sample per second. Sample frequency. Okay. So it is 2 hertz means තප්පරයකට sample දෙකක් ගන්න. Okay. එහෙනම් එක sample එකකට යන කාලය තමයි 1/2. ඒ කියන්නේ 0.5 second. Okay. So this is the sampling time taken to get one sample. Okay. මෙන්න මේ equation එක දාලත් ඔයාලට මේවා කරන්න පුළුවන්. මේක අර උඩයට මාරු කරන්න. Fs සමාන 1ට Ts අපි මේ relationship එක ගත්තා කලින්. හරි. ඒ relationship එකේ equation එක fs මෙතෙන්ට දාලා ts උඩට දැම්මා. ඒතකොට ts සමාන 1ට fs. හරි? හරි? එතකොට fs දීලා තියෙනවා 2 Hz. ඒක මෙතෙන්ට ආදේශ කරොත් 1ට 2 Hz. ඒ කියන්නේ 0.5 second. Okay? sampling time එක 0.5 second. 0.5 second sampling time. ඒ කියන්නේ මම sampling එක start කරනවා t සමානයි බිඳුවේදී. ඊළඟට sample ගන්නවා හැම 0.5 second එකකටම පස්සේ. හරි? දැන් මම ඒ signal එක අඳිනවා. Now I am going to draw that signal. Okay? Now I am going to draw that signal. Okay? So what happened? I am starting the sampling at t is equal to 0. At t is equal to 0, I switch this on. Okay. So I can get the voltage sample. Okay. So what is the voltage value I get here? This is this one. 5 volt. Okay. So I get 5 volt. Again after 0.5 second. Again after 0.5 second, I get another sample. Okay. I just turn off this switch and again turn on this. Okay. That means I am getting another sample. Okay. So that means I'm getting a sample from here at 0.5. So what is that number? That value, that is 2.5. Okay. So here I get another sample that is 2.5. Okay. Again after 0.5. That means at 1 second. Again after 0.5. After 0.5, I get another sample. So I am getting the sample here. Okay. So that is 1.25. Okay. So I am getting sample here. It is 1.25. Okay. Again after 0.5 second, I am getting another sample. That means at 1.5. Right? That means this sample. That is also 2.5. Right? 2.5. Again after 0.5 second. Okay. That means at 2 seconds, I am getting another sample. Okay. So that is equal to 5. Okay. So I am getting another sample. So that is equal to 5. Okay. So this is the signal I get. Okay. I will try to draw it again clearly. Okay. I will try to clearly draw it. Okay. Please try to understand this. Okay. So this is okay. So I am starting the sampling at 0. That means at 0, I am getting one sample. Okay. My sampling time is 0.5 second. That means after 0.5 second, I am getting another sample. Again after 0.5, that means 1, I am getting another sample. Again after 0.5, that means 1.5, I am getting another sample. Again after 0.5, that means 2 seconds, I am getting another sample. Okay. So this signal duration is 2 seconds. Okay. So at 2 seconds, I stop my sampling. Okay. So, so when I on this switch at t is equal to 0, so what is the voltage value? That is 5. Okay. So I get 5 here. Okay. I get 5. Okay. So that is the voltage value, 5. Okay. Then again I off it. Okay. Then 0.5 again at 0.5 second, I on it again. Okay. Okay. Then again I get the voltage sample. Okay. So that is equal to 2.5. Here it is 5 volt. This one is 2.5 volt. Okay. So I get another sample here. So that is 2.5. Okay. Again after 0.5 second, I am getting another sample. That is the second sample. So it is 1.25. volt. Okay. So I get another sample that is 1.25. Okay. Again, after 0.5, I get another sample. So here I get the sample. I am off this switch and on. Okay. So after again at 1.5 second, I on this switch. So I can get the reading. Okay. So it will be 2.5. Here. Okay. Okay. Again after 0.5 second, that means at 2 seconds, I am on this switch. So I can get the sample, this, okay? So that is, this will be 22.5 volt, and fourth sample, here I will get again 5 volt. So I will get another sample here, 5 volt. Okay? So this is this signal, okay? This is a continuous time signal, okay? So this is T, this voltage is changing with respect to T, okay? So it is a function of time, okay? So this is a function of time, okay? Okay. Now I got, I sample that signal. I sample that signal, then I can get the discrete time signal. This is continuous time signal. After sample it, I get the discrete time signal, okay? I get the discrete time signal, okay? So I can get only some sample here, okay? So this is the 0th sample, and this is the first sample, this is the second sample, this is the third sample, and this is the fourth sample, okay? So you can see that, okay? So if these are sample number, okay? These are sample number 0, 1, 2, 3, 5. These are sample number. These are sample number. Okay, these are sample number. 0, 1, 2, 3, 4. These are sample number. Okay. So I get some sample number. Okay, I just put some sample number. Okay. Okay. And this is the discrete time signal. And you can see that there is a corresponding time value for this sample number. No? The mama may signal like a gata, like a point 0.5 වලින් මම sample ගන්නවා signal එක. හරි. එතකොට මට එනවා මෙන්න මේ sample ටික. හරි. එතකොට මේක තමයි බිඳුවෙනි sample එක, මේක පළවෙනි sample එක, මේක දෙවෙනි sample එක, තුන්වෙනි sample එක, හතරවෙනි sample එක. එතකොට ඒවට කියනවා අපි sample number. හරි. ඒක sample number එක. හරි. හැබැයි ඒ sample number එකට corresponding time එකක් තියෙනවා. For example, 0th sample number you take at 0 second. First sample number you take at 0.5 second. Second sample you get at 1 second. Third sample you get at 1.5 second. Fourth sample you get at 2 second. Okay. මේ හැම sample number එකටම corresponding අදාළ මොකක් හරි time value එකක් තියෙනවා. Okay. But keep remember that when we represent or when we draw the, this is very important, okay? When we draw the discrete time signal, we normally doesn't use time variant. We doesn't use time variant. Instead, we use sample number. Okay, normally referred in N. Okay, so this is very important. You should remember this one. What is this? අපි discrete signal එකක් හඳිනකොට when we draw a discrete time signal අපි සාමාන්‍යයෙන් t පාවිච්චි කරන්නේ නැහැ. ඒ කියන්නේ time එක පාවිච්චි කරන්නේ නැහැ. We generally doesn't use time. We generally do not use time. Time එක වෙනුවට අපි පාවිච්චි කරන්නේ මෙන්න මේ sample number එක. හරි? Instead of time we use sample number, that is n. N. That means this discrete time signal we normally draw not with respect to t, but with respect to n. Okay, n. What is this n? That is sample number. That is sample number. Okay, this n is sample number. Okay, we called it sample number. But there is corresponding time value for each sample number. Okay, there is corresponding time value for each sample number. So that is very important. Okay, so when we draw a signal, we normally doesn't use t, instead we use n, that is sample number. Okay, but you have to remember that for this every sample number there is corresponding time value. Okay, so that is very important. Hari, අපි සාමාන්‍යයෙන් signal එක discrete time signal එකක් අඳිනකොට time පාවිච්චි කරන්න ඒ වෙනුවට පාවිච්චි කරන්නේ n. හරි, අපි කෙලින්ම n පාවිච්චි කරන්නේ. හරි, හැබැයි මේ n ට අදාළ මොකක් හරි time value එකක් තියෙනවා. හරි, okay. මේ n අපි කියනවා sample number එක කියලා. This n we called it as sample number. So what are the value this n can take? එතකොට මේ n ට තියෙන්නේ මොන වගේ value? ඒක sample number එකක්. It is a sample number. So it should have an integer value 0, 1, 2 likewise. Okay, so this should have an integer value. 1.5 ඒ කියන්නේ 1.5 sample එකක් එහෙම කියන්න බෑ. 1.2 sample එහෙම කියන්න බෑ. හරි, ඒක integer එකක්. Sample number එකක්. It has an integer value 0 sample, first sample, second sample, like that. Okay, so this n is an integer value. Okay, it can be plus integer value, definitely, no? So here you get plus integer value 1, 2, 3, 4. Those are plus integer value. Okay, and it can include 0 also. It can include 0 also. Okay, and if you know that when we draw a signal, sometimes we have minus time value. If the minus time value is there and you get the sample in minus time, these are minus sample number like this. Okay, so there can be minus integer also, including 0. Generally, okay, generally this n will have the integer value from minus infinity to plus infinity, including 0. Okay, so these are integer, -2, -1, 1, 0, 1, 2. Likewise, these are integer. These are only integer. Plus or minus integer. This n can be plus or minus integer, including 0. That is very important. Okay. Okay. So this is very important. Okay, this is very important. Okay, so again I draw that signal. Okay, so my discrete time signal is like that. Okay, so this is n. Okay, this is n. Okay, this is n, and so 0th sample is 5. The first sample is 2.5. Third sample, second sample is 1.25. Third sample is again 2.5. Fourth sample is again 5. Fourth sample is again 5. Okay, so this is sample number. Okay, so this is how we normally draw a discrete time signal. Okay, so you you see that now the continuous time signal, that is a function of t, because we use t for independent variable. This is the independent variable t. Okay, so we use t for this to represent this signal. Okay, to represent this function. So this function is a function of t, xt. Okay, but here we use n to represent the discrete time signal. So this discrete time signal is a function of n. Okay, so normally discrete time signal are normally represent using as a function of n. Okay, as a function of sample number. Okay, so discrete time signal are normally represent as a function of n. ඒ කියන්නේ sample number එකේ function එකක් විදිහට sample number එකේ function එකක් විදිහට like xn. Okay, in this way you can represent the signal. Okay, now very important, can you figure out any relationship between this n and time? Okay, so you can see that this is 0 second. Okay, can you remember that this is 0.5 second, this is 1 second, this is 1.5 second, this is 2 second. Okay, so these are the corresponding time value. These are the corresponding time value. These are the corresponding time value. Okay, okay, the corresponding sample time value. Okay, so what is the sampling time? Sampling time is 0.5, no? Okay, so this is 0. Okay, and this is 0.5 second. So this sample is 1. Okay, so if you multiply 1 from sample value, you get that value. Okay, so this is a second sample. If you multiply second sample from sampling time, you get, this is the first sample time, and this you will get second sample time. Okay, and so on. And if you multiply, for example, if you get the nth sample, okay, nth sample or simple n sample, let's say that you are going to get nth sample, okay, and if you multiply that nth sample by sampling time ts, you get corresponding time value. Okay, so if you multiply the sample number with the sampling time, you get the corresponding sample. Okay, so this is also a one relation. Okay, so you need to understand how you can how you get this. Okay, how you get this. Okay, so try to understand by yourself how this equation get. So it is very simple, no? Because this first sample, you have to multiply the sample number with the sampling time. This is sampling time, and this is the sample number. So by multiplying sample number with the sampling time, you can calculate the corresponding time value for a sample. Correct? Okay. So this relationship also there. Okay. So try to understand these things by yourself. Okay. This is very important. Okay, and we will do more exercise. Okay, in our next interaction session also we will do more more exercise using this sampling. Okay, so these are very important. Okay, so what you should know is, okay, what is sampling. Sampling is the process of converting continuous time signal into discrete time. So how you are going to sample, how you sample it? Okay, So it is just like you are sending your signal through a switch and you on the switch at the sampling time. Then you can collect the voltage or the corresponding amplitude sample. That is how you are going to sample. Okay. And sampling time is equal to 1 over sampling frequency. Okay. Sampling time is the number of sample per second. Sorry, sampling frequency is the number of sample per second. Sample time is the time to take one sample. Okay. You need to understand this one. Okay. And when we draw discrete time signal, we do not use the time variable. Instead, we use n, that is the sample number. Okay, so that sample number can be from -infinity to +infinity, any integer, including 0. Okay, so the discrete time signal is normally represented as a function of n, function of a sample number. Okay, and each corresponding sample has a corresponding time value. Okay, so corresponding sample number, if you multiply it by the sampling time, you get the corresponding sample time, sampling time. If you multiply your corresponding sample number from the sampling time, you can get the corresponding time for that sample. Okay, so these things you should keep remember. Hari. Okay, so I will give you one homework to do. Okay, I will give you one homework. Okay, homework. Okay, so now I am going to give you two signals. Okay, I am going to give you two signals. One signal is xt is equal to 5 e to the power minus 3. Okay, this is one signal. Can you remember what is this signal? This is exponential signal. This is an exponential signal. Exponential signal. Okay. Okay. Now you are going to sample this signal. You are going to sample this signal with sampling frequency is, let's say that 100 hertz. Okay. So you are going to sample this signal with 100 hertz. Okay, 100 hertz. Okay. So this is first example. Second example, I'll give you another one. Xt is equal to, let's say that 2 sine 2 5 42 42. Okay. Now you are going to sample this signal from 80 hertz. 80 hertz and again 160 hertz. Okay. So try to, so here also you have to find the xn. Okay. Here also you have to find the xn and you have to draw it. Okay. Here also you have to find, let's say that this is, you have one frequency x1, and let's say that here you will have another signal x2, discrete signal. Okay. So try to draw these x1n and x2n and this xn. Okay. Try to do this question at home. Okay, so you will get this kind of question to your exam. Okay, so these are in exam type question. Okay, these are exam type question. These are exam type question. Okay, so if you can draw a signal to this kind of one, okay, so you will get maybe 10 marks for an exam, for your final exam. Okay, please remember that. at least you have to get some marks, okay? I am expecting that at least you can get 30 marks to the paper, okay? 30 marks to the paper. Try to get at least 30 marks to the paper, okay? So what you have to do is, I am giving you some question. You need to try those question by yourself, okay? මම දෙනවා question එක ඔයා තනියම හදන්න ඕන. හරි? And if you can't do that question, මොකක්ද එක question එකක් හරි හදාගන්න බැරි නම්, please come and meet me and ask. හරි? හදාගන්න බැයි නම් ඇවිල්ලා අහන්න කොහොමද මේක කරන්න කියලා. හරි? එතකොට මට ඒක කියලා දෙන්න පුළුවන්. Okay? So, please bring this homework when you come to the interaction session in next. No, I think before the interaction session, we will have one session, okay? No, I will give, okay? So we will have next interaction session, okay? Please bring this, try to do this question and bring the answer to the next interaction session, okay? So it is in next Friday, okay? That is in next Friday. Friday, 9 to 10. Okay, 9 to 10 minutes. Okay. So at that time, we will try to do this question, okay? So if you have any question, you can ask me now. මොනවාරි ප්‍රශ්න තියෙනවා නම් දැන් අහන්න පුළුවන්. ක්ලියර් කරගන්න පුළුවන් ඔය කට්ටියට. හරි?